Hi, this is Kevin DeYager from the Esgyn product marketing team, and I'd like to invite you today and give you a warm welcome to our Delivering HTAP on Hadoop webinar. I'm joined today for this webinar by Rohit Jain, our Chief Technology Officer. Rohit.
Hi. Hi, Kevin.
And Kakarlamudi, our Head of Pre-Sales and Principal Architect.
Hello. Hi, Kevin.
Thank you. Let me just begin this webinar in talking about HTAP and why we're here to talk about hybrid transaction and analytical processing, which is really this new model or paradigm that's been evolving of how you can bring different types of workloads together on the same platform, on the same data. And really, when we look at this from a higher level, we look at there's a whole set of different requirements being driven by the 4 V's, that you're familiar with, the volume, the variety, the velocity, and the veracity, these 4 elements of big data solutions. So, Rohit, why don't you talk a little bit more about what these requirements are that are changing for these workloads?
So these workloads in the past have essentially transactional BI and analytical workloads have all been on different platforms. And basically you had data that was moved from one platform to the other to accomplish these different sort of workloads. And that's because of the latency issues, the high volume, the velocity, and so forth, so on, and the whole real-time nature of things, that latency is not acceptable anymore. And what's happening is the customer's expecting the transactions and analytical processing to be done simultaneously, almost in real time against the same data. And so HTAP was a term that Gartner came up with to describe this, and they use it more in an in-memory context. Now, we all know that while you can actually do quite a bit in the memory these days, there is still a large amount of data that cannot be put in memory because it's not non-volatile. And so you have to essentially have persistent data storage and be able to have an HTAP story around both persistent data as well as in memory. And so we are going to talk about that aspect of it. And the other value of having analytical processing and all that is that it's and transactional of the same engine is that you have much better insight. You have operational data, you have historical data, as well as you have analytical data all on the same platform. So if you get some big data, you get some comments or some Twitter comments on your product, and you want to understand what the implication of that is, first you have to understand what the historical performance of the product has been. And then in that context, you have to see what the operational current OLTP performance or the transactional performance of the product is. What are the sales doing right now? In that context, to be able to see if you need to react to it, how soon you need to react to it, and so forth. So you really need to get that entire perspective. So that's one aspect, this whole workloads, of transactional through analytical. The other aspect that we actually extend beyond what Gartner talks about is this whole the data models, and we have seen that the pendulum swung from relational databases to NoSQL databases. And now there are various different data models and data structures that go into servicing operational as well as analytical workloads. So that really has to be part and parcel of the discussion, because if you're going to talk about HTAP, you have to talk about the data and the structures of the data, the variety part of this 4 V's. And those are the 2 things we're going to focus on. Of course, there are other trends in the market. There are other requirements that are important as well. One is the streaming paradigm, where with real-time operational and analytics, we sort of touched upon that as part of HTAP. We also discussed the in-memory computing as part of HTAP, and that's something that's coming up that all databases and query engines have to address. And finally, of course, a little bit orthogonal to this is the whole cloud deployment, where you need elastic scale. You need to be able to scale, very fast. You need to be able to deploy very fast, and that's the cloud aspect of the requirements that have been driven by these 4 Ps.
Yeah, so Rohit, I think that you mentioned that this differs somewhat from the Gartner model for HTAP, which is primarily in memory, and that's similar actually to the model that Forrester also has that calls it translytical workloads. I think that one of the really important points that you also bring out about that is that what's different from that is you're also bringing in semi-structured and unstructured data, this public data, this social data, all this new types of data that we're getting in big data workloads. Traditionally, I think these HTAP and translytical workloads have really focused more on structured data, maybe even on something that's structured in terms of a key value pair or standard SQL, but not the tables, but not what these new data types are bringing and the new types of data you need to manage as part of it. So I think that's a really important point.
Right, and I think, so yeah, it's a trend we cannot ignore, which is really part of this whole operation. So we had RDBA, MSS, and the issue was that they were high TCO, total cost of ownership. They lacked elastic scalability. They did not really do semi-structured and unstructured data as well. And there was schema flexibility issues. I mean, you're not flexible in schema. So essentially that led to this whole NoSQL revolution, where people started using key value stores and the big table concept, the white column stores, document stores with JSON, text search, through things like Lucene, graph databases and so forth, and column stores, which are also very flexible in that they support some forms of semi-structured as well. So people started moving to this paradigm because they leverage these in both operational and analytical workloads. But the problem is that the skills that were prevalent in enterprises were really SQL skills. Existing tools and infrastructure was all SQL. There is a need for asset transactional support in a lot of cases. It's sometimes more efficient to do joins and so forth that can be done by these databases. And it's certainly a lot harder to do coding with MapReduce than to SQL. So the pendulum sort of swung back again, where people wanted to leverage SQL. But the issue still is that you've got all these different data structures, so you got these different interfaces, and you have to glue all these technologies together and use different technologies to address your workloads. So the point is that what we need is to simplify this and have really a single query engine that can provide a lot of those capabilities that you need from a data modeling perspective, so that it can address the appropriate operational to analytical workloads, along with actually addressing those workloads itself. So,
well, thank you, Rohit. Let's talk a little bit more about these workloads, because I think it's important for people to understand what we really mean from going from transactional all the way to analytic, and what are those characteristics of those workloads are.
Right. So the workloads essentially span two aspects. So one is things that are essential to operate the business, like online transaction processing and operational data stores. And then there are aspects to improve the performance of the company, like BI, reporting, and analytics, which are used to improve the product, improve customer experience, et cetera, right? So, and usually OLTP systems are very transactional, very sub-second response times. You usually have a customer waiting, doing a transaction on the other side. So there's a customer experience issue on there. There are large update volume and very high concurrency. Whereas with operational data stores, they generally are fed into from OLTP, and they are like things like where you're back ordering, where you have the order now, but you are now filling up the order, you're following up with suppliers and supply chains and so forth, so on. So they do require some transactional updates because the orders get updated and shipped out and so forth. But there the requirement becomes more sub-seconds to seconds for queries. And it's a lower update volume, but some historical data, because now you have some context that you have to follow up on these items and so forth, so on, until maybe a month or so. And then, of course, that data is not relevant for operational purposes, and then you can move into the BI space. When you move into the BI space, it's mostly non-transactional. It's seconds to minutes, and you got more batch or streaming feeds coming in from OLTP and ODS, and it's historical data, and it's a low to high concurrency in nature. And analytics even goes farther, because it could be minutes to hours, depending on what kind of analytics you're running against it. They have aggregations going on, and there's historical and big data, which is integrated, and it's low concurrency. So basically, you've got the spectrum of workloads, and really the line between operational and BI and analytics is really disappearing. And basically, you want the same data to be processed for all these different workloads to meet these different needs that are, real-time needs.
So let me make sure I understand this. So what you're saying is that these traditionally, these workloads from OLTP and analytics had this sense of latency, had all this issue around data movement and data duplication. But what we're trying to do here is bring it all together onto a single platform within a single environment, but also reducing the latency, so actually putting analytics within the transactional part of the application as well.
That's right. Exactly.
So one of the things, as Rohit pointed out, right, so, well, how much this is going to fit in the memory, right? If you really look at from, right, low latency all the way to the batch processing, there's a lot of data, right? The volume is increasing. You may not be able to fit that in the memory. So you need to have a solution where it leverages both memory as well as the disk efficiently.
Right, so you're really talking about this concept of having the hotter data in memory, right, and the colder data on disk, right, in an optimized format for how it's going to be accessed, right?
Yeah.
Right. Very good. Thank you, Rao. Let's talk a little bit about what this looks like within a Hadoop ecosystem environment, because I think it's important for us to understand that we're talking about bringing HTAP, which many people talk about using proprietary technologies. We really want to bring that forward within the big data world within a Hadoop ecosystem.
Right. So what we were alluding to when we talked about this whole NoSQL, pendulum and swinging and so forth, is that technologies like HBase and Cassandra and MongoDB and JSON are pretty much being used for transactional applications or operational applications. If you look at the NoSQL space, and then you have the ORC and Parquet, which are column stores, and Kudu, and all these are addressing more the analytical type of market, the BI and analytical type of market. So you have all these different data structures trying to address these different workloads and capabilities and models, certainly. And then on the top of that, you've got these different query engines that are trying to address those different pieces of the market, and they're trying to integrate like Trafodian and Hawk and Presto and Tez and all the way to Spark. So there's a pretty complex set of products there that if you want to leverage, you would have to leverage multiple products to be able to get the value from these different data structures or models that you want to have. And in fact, on the in-memory side, you have Apache Geode and Ignite, similarly, that provide the in-memory aspect of operational through analytical processing. And so what we really want is reduce that complexity so that you have a single query engine that can do all this for you and work against and provide you both relational aspects as well as leverage the data models that you need for operational through analytical processing. So,
yeah, I think one of the important points you're bringing up, Rohit, is the application tier, right? So you have an application tier which is accessing these different data. If they are accessing these different SQL engines, then you need to add that complex logic, right? Whereas bringing with a single query engine, your application migration is at ease. So it's seamless to an application level. So because it's just trying to deal with one SQL engine.
Exactly. I think it's the application simplicity, the skill set that you need, and from an operational standpoint, how do you manage this from an operational standpoint and get to end-to-end performance perspective and manage these, and it becomes a big issue from a skills and cost perspective. And so simplifying that can really benefit quite a bit in the infrastructure.
Okay. So Rao, why don't we talk a little bit now about what these solutions look like, right, within an architecture?
Yeah. So going back to Rohit's point, right, I just want to emphasize, right, well, this concept is existing, right, it's there, but what exactly per Gartner, what HTAP from their perspective is trying to solve for one of the four major drawbacks from traditional approaches, right? The first one is for analytical HTAP workloads, right, data does not have to move from operational to analytical, right? That is one of the points they emphasize on. Another one is as the transactional data is coming in, it should be readily available for analytical reporting purposes. And the third one is you should be able to drill down to these aggregates so that the applications are looking at the fresh data, right? And the last one is whether try to eliminate or reduce this multiple copies of this data, right? And that's what this HTAP they talk about when they're talking from HTAP perspective, and which is what our Trafodian can really provide that, right? Our engine, because we came from transaction world and then we moved into operational data store to BI, and that's where with this particular engine, as Rohit pointed out, a single engine it will be able to provide you all these capabilities. So if you look from our solution perspective, right, what we do is we support different type of data formats, right? We support unstructured and then structured and semi-structured formats, right? And then we have a very advanced UDF infrastructure which acts as a consumers, right? So if we have a streaming data coming in, well, they can consume this data, for example, from Kafka streams. As the data is coming in, it can consume, or it could be from a Spark stream, it can consume the data. And as the data is being loaded into Esgyn, so for example, in this case, what we try to do is with the hot data, we keep it in HBase because we provide transaction capabilities and the asset guarantee. And then you should be able to report at real time. Right now, as the data is coming in, you can report it. And then as your data is getting colder, which is where you want to keep it for historical analysis, and then we seamlessly move it into ORC format. Because one of the things we found from our use cases is HBase is really good at from transactional capabilities, right? Especially if you are looking at your workloads where your rapid ingestion at the same time you want to do real-time reporting. For shorter scans, yet it performs really well. But as your get data is getting matured and you want to move it, and then you are looking for your especially advanced algorithms where you want to do a lot of large scans, and then ORC is very well suited for that. That's why we choose that. And then we try to move this data seamlessly. From the application perspective, it is seamless. They don't have to worry about it. And still it looks to them as the same table. And we take care of underneath. And also what we can do is with our UDF framework, you can bring in external feeds. And then you can join this hot and cold data as well as external feeds for your reporting purposes, especially for your advanced analytics. So what we are saying is, well, this is a complete mixed workload environment where we support, right? We support as your transactions are coming in, you can do the reporting as well as in the background you can run your deep algorithms. So that's what this environment can provide you.
Yeah, I think it's important to point out here, and you mentioned things like Apache Kafka for streaming, and our integration with Apache HBase and Apache Orc for the file storage engines portions of it. I think it's really important to mention that it's not just connecting to them, it's really deep integration and optimization with each of these as well that we do. True. Right, with Esgyn DB powered by Apache Trafodian. Yeah. And I think the other part that you've also shown in this diagram is that there is also some things we just integrate with, which is the presentation layer with Zeppelin and Q, because it's just standard ODBC and JDBC interfaces to plug into for that, right? True. Which gives you, and this goes back to providing a single common application environment that accesses the data regardless of its storage format, and even with the UDF infrastructure to potentially access external data sources. True. Right. That aren't even brought into this Hadoop environment.
Correct.
Right.
Yes. Yeah.
So I think that's important to show how we're really using this diagram is good because it shows how we're using and integrating within the Hadoop ecosystem, taking advantage of the innovation that's happening there in different areas, but really focusing our efforts and our development and research efforts into the query engine and optimization for that, right, around SQL. Right. So if we look at this, Rohit, what are really the challenges that need to be within a query engine you need to address to be able to support HTAP?
Right. So, trying to do HTAP is really hard because, if you look at where the focus has been, these different databases, proprietary databases even have focused only on certain workloads. You've had Oracle, focusing mostly on OLTP. You have Teradata on BI, and you have, things like Vertica on analytics because, they were separated workloads. And so you had to focus only a small set of things. And you see that in the Hadoop world as well. But what we have is we have the heritage and experience to actually cover the entire gamut. And the challenges are, in a single query, how does a single query engine, have address these different workloads for like a serial plan, for a OLTP type query, and an operational query versus a very complex analytical query. And so you have to be able to deal with serial plans and parallelism. You have to be able to figure out whether you want to use nested joins versus hash joins, and where where not to use a nested join, and so forth, so on. And so, and how do you leverage indexes very well for operational queries and so forth. So there's a lot of work required in order to be able to support the entire spectrum of workloads. The other part we talked about is integrating into these different storage engines. And as we mentioned, as Rao mentioned earlier, we were using HBase for low latency and ORC for analytical processing, because those are the engines that are good at each of these things. And so we integrate into these different data models and the storage engines so that we can provide the best capability in that area. But it's hard to do. There's a lot of things that need to be done in order to support them effectively, so we can take the leverage these particular storage engines to the best of their capabilities. And that's the second piece. And the third piece is really, how do we support these different data models that people are used to, not only in the normal form, third normal form, and star schema, snowflake schema, but also these new data models of key value documents. To how do we support JSON and text search and graph and com stores and so forth. So these are the other challenges that we have to sort of say, so we have a single query engine that can do all that. And finally, enterprise capabilities are very important, because you have HA requirements. What are your HA requirements? Is it 4 nines or 5 nines? Do you need all online operations? How do you handle security? And then manageability. How do you get performance metrics? In one case, you're getting transactions per second. On the analytics, you're getting seconds per query, so you have to report them differently. You have to be able to handle all that metrics. And then also, you have to do workload management. How do you balance the priority of short-running fast queries for operations against long-running, high-resource consuming complex queries? So all of these things have to be addressed, and so it's very challenging to do that. And since we have a heritage that sort of we've worked in both operational and analytical, we actually have an architecture to address that.
Well, let's now dive a little bit into that architecture and what that looks like.
And so what we have is Esgyn DB then has this data connectivity and workload management services, which sort of tries to manage these different workloads. Our optimizer makes the choices of what kind of plan should be used, a serial plan, a nested join, or whatever, depending on whether it's an operational query or it's a analytical query. And then, of course, we are leveraging our data flow execution architecture, which is like a DAG architecture, to really work against Apache HBase or ORC to leverage, as Rao was mentioning, to be able to deliver the results of the query that you're looking for, whether it's operational or analytical. And then we have the stable user-defined function capability, which sort of extends the capability of Esgyn DB to be leveraged for some of these other data models, and like Lucene for search and JSON and so forth, so on, that we can integrate those different data models. You have a distributed transaction manager that essentially provides the transactional full asset transactional capabilities, and then the Esgyn DB manager, which provides all the metrics and the performance monitoring and so forth, so on, that we talked about. And we offer this in the cloud, so we run on the cloud, so we have full elasticity, support for this. And our focus initially was operational data store and OLTP, and so we integrated asset transaction to HBase. We provide cross data center disaster recovery, point-in-time recovery, elastic scalability, concurrency, and of course there's things like multi-dimensional access method to leverage this indexes very well. And all of this is really geared towards call center application, web scale applications, and operational offloads that are onto Hadoop. But now, as you have streaming mechanisms coming in, and the use case that Rao was talking about earlier, where you have the Kafka stream coming in, and we are acting upon it, and we are triggering alerts and so forth, so on. We are also rendering operational dashboards that can be rendered, and essentially people can monitor what's going on in real time with Zeppelin and Hue and those kinds of technologies. And eventually, both the OLTP data and the Internet of Things kind of data feeds into this data lake where you have other data that you might be sourcing in, so that you do transformations and make that data cleansed and transformed so you can leverage it, normalize, so you can roll up and aggregate it, and then you can report on it and do analytics on it. And that's where we are leveraging things like Spark and integration with, for in-memory type operations and analytics, and Lucene for text type capabilities. And that's where we provide the reporting and analytics on this. So, and then finally we have ODBC, JDBC, and ADONet and Hibernate interfaces provided so that you can build your applications on the top of this infrastructure to leverage all these capabilities.
I think one of the important points you brought up, Rohit, is especially in operational data store, right? You need to have these multi-data center support, right? An active or disaster recovery, right? And then that is very critical, especially when you're deploying on a multi-data center. Another thing also, one question I wanted to ask you, Rohit, is like we see from our customers more and more, they're moving away from ETL to ELT, and then hopefully they're thinking like, can we really eliminate that process?
Right. And I mean, I think there is going to be a time before this can be completely eliminated, because of course people already have OLTP systems and they still have to feed in. But even those, what's going on now, that they are trying to feed it in a real-time fashion, right? Change data capture and in a streaming fashion into this infrastructure. But more and more, as new applications develop, they want to feed directly into the Hadoop infrastructure and do ELT instead of spending a lot of time in latent processes doing ETL kind of workloads. And so that you can essentially do it on platform in parallel, very fast, and all the data is available for right away for analytics and so forth. So
yeah, when I look at this from both of your discussions on this, I get a really key takeaway for me is to really build an HTAP solution, right, that you can deploy as a user. You really do need these traditional enterprise database capabilities, particularly around manageability, around security, about data recovery and protection capabilities, right? And because that's what's really driving from the operational side, those traditional systems, which is not traditionally where Hadoop is bad, right? It definitely, security is an area where Hadoop is definitely recognizing once you're pulling all this data together, that you need to have that, right? And that's one area where the Hadoop distribution vendors have been putting efforts into play. But, point-in-time recovery, the cross-data center capabilities, those type things, and even, the workload management as well, to put both of these on the same platform, are really in areas where I think Esgyn DB and our continuing efforts in R&D are really where we're differentiating. Right.
Yeah, very, very much true, Kevin, especially in the mixed workload environment, right? You need to have those capabilities like a workload manager where because you're looking at the multiple workloads, right? You have ingestion. You may want to give that a high priority, as Rohit pointed out, based on your SLAs, right? Because your stream of data has to come 24/7. You cannot take any downtime on that, right? At the same time, maybe you could have an ad hoc query running. Maybe that can take a hit, right? Your SLA for that could be a different, right? And then you may have real-time queries. So especially in this environment, you need to have that capabilities. And to do that, you need to have a good optimizer, as Rohit pointed out, right, which understand these workloads and then try to teach the runtime engine how to collocate where the data is, right, so that to reduce the data movement, right, which is what Esgyn can really deliver on that.
And I think people think that if you've got Yarn or Mesos, maybe the problem is solved, but the problem is the Yarn and Mesos are actually working at a much higher level, at an application level. We would be considered like a database application query manager. Right. And within that, you're doing it at a query level. And certainly Yarn and Mesos don't really handle things, workload management at that level. And it's absolutely necessary that you have that, otherwise your high priority queries won't be serviced along with your low priority.
Or you're supposed to continue to have siloed applications where you can then manage the SLAs of call center operators that might need to get information within, half a second versus the longer running, report queries that can run at a slower pace.
That's right.
Exactly.
Right.
Exactly.
So I think we've talked a lot now about the requirements and the architecture, right? And what the requirements are of a solution that's going to support HTAP. Let's now talk about what we've experienced with working with some of our early customers and proof of concepts that we've done for workloads that have HTAP characteristics.
Yeah. So, for one good point, Kevin. Let's take one of our customer, right, Webroot. They fit into this use case very well in case of HTAP because it's a security company where they're looking at the clickstream data coming in, and at the real time they want to make decisions, right? So they have a dashboard for their customers where they can come and look at that, what kind of websites their enterprise users are going, so that they can do real-time analysis, right? So it's in the cloud. It's hosted on the cloud. The data is coming in at the rabbit pace, and then they're looking at the real time, and then to make decisions. At the same time, they keep this data for 13 months, and then it's a huge volume, and then to do some deep analytics on this data, right? So it's a perfect mixed workload where they're looking at the real-time data as well as historical data, and then which is what this particular HTAP fits in very well. And then we were able to deliver that with Esgyn engine.
Well, that's great to hear that, and I think another point around that is, again, if we look at it from an IT perspective, we're delivering something at a lower cost that takes advantage of the Hadoop ecosystem, right? That's really driving that lower cost as compared to proprietary HTAP solutions, right? And also supporting multiple workloads from the transactional to analytic on that. But I think if you also look at it from a perspective, what business benefits did they get from this, as opposed to just sort of the IT, I was able to build it and run it cheaper, right? What in terms of their business did they actually get?
Yeah, same, which is Rohit covered, right? Because previously they were moving the data, right? They had silos, right? They have different databases managing, right? And then they tried with some of the NoSQL databases, but it was not performing well. They were not meeting SLAs, right? Some of the problems they were trying to explain with, it's not able to do aggregations, it's not able to do joins, right? Which is where we were able to solve. And then at the same time, everything, the data is in one place, right? They reduce the data movement. And now in the next step, they're saying that maybe I want to keep the data more than 30 months. Maybe I want to keep the data for 4 years. So for them to do data mining, right? And which is perfect for us, because that's why when we are transitioning, we are providing this org facility where we seamlessly migrate the data, and then they can do deep analytics on that, and then which is where they were trying to expand this.
And then also, I think you were also mentioning that the customers can now access this data directly, and the latency has been reduced dramatically in that whole process.
Exactly. Because before, right, the reports were not ready. They used to wait for a day or two, and now they can come log on anytime and then able to see the data at real time.
Right. So it's actually then showing how they're improving their product, which is a service, right? And making it, differentiating it because the data is more actionable by their customers, as well as also making it and maybe develop even new solutions around historical analysis of that data, right? So that's a good point. What other customers do we have that have workloads or proof of concepts we've done, which have workloads that are have HTAP characteristics as well?
Yeah, so there's another very interesting application which actually applies to a lot of these fleet management type,
so an Internet of Things type application.
Yeah, and basically you've got transportation system where you're trying to track, how your the buses are doing. For instance, you're sending sensor data every 10 seconds, telling you the location, telling you if they have an issue, there's a breakdown or a problem. And so from an operational perspective, you can start looking at this data coming in, streaming in, and you can have operational dashboards showing, what's going on and what action needs to be taken. You can have alerts and thresholds, basically that alert you when something like that happens, so you can act upon it from an operational perspective. But also you want to do the analytical processing, just like in the Webroot use case, where you want to see how you can improve that whole process. How you can find different routes maybe, or different timings, or what preventive maintenance you can do in order to address some of those issues on a longer term basis. So those are the kind of business applications that are relevant.
Yeah.
Well, thank you, Rao and Rohit, for joining me today on this webinar where we talk about what it required to deliver HTAP Hadoop solutions. And for, well, thanks to our participants on the call live or who are joining us in the recorded session of this webinar. We have available to you a copy of, and it's actually a hard copy, not an electronic copy, a hard copy of the book In Search of Database Nirvana that Rohit Jain authored and was just recently published by O'Reilly. And we have free copies that will be sent to the live webcast registrants. And if you're watching this as a recorded webinar, if you send me an email while supplies last, I'll also send you via your postal email a copy of this book. So again, thank you very much. And we look forward to having you learn more about Esgyn DB at www.esgyn.com. Thank you.
Thank you.
Thanks.
Thank you.